Hello dear friend, welcome to my YouTube channel, Practical Based Study Material. This is Santosh Sarode, Mechanical Engineer. Today I am going to explain how to solve the numerical based on Spur Gear. So in this video, I find out the different parameters when two Spur Gear are meshed with each other. So in this numerical, to find out the length of path of contact, the length of arc of contact and velocity at the beginning of point, meeting point, velocity at the pitch point and velocity at the disengagement point. So without wasting time, dear friend, please like and subscribe my channel. So let's start the first numerical based on this Spur gear. So example, a pair of gear having 40 and 20 teeth respectively are rotating in mesh. The speed of the smaller being 2000 rpm. Determine the velocity of sliding between the gear teeth face at the point of engagement, at the pitch point and at the point of disengagement. If the smaller gear is the driver, assume that the gear teeth are 20-degree involute form. Addendum length is 5 mm and module is 5 mm. Also find the angle through which the pinion turns while any pair of teeth are in contact. The solution. In this numerical, we are finding out the velocity of sliding, point of engagement, at pitch point and disengagement. And also we are finding out the angle through which pinion turns. So the given data is the teeth on bigger gear 40 and smaller pinion 20, that's why capital T and small t. Speed N1 2000 rpm, angle phi 20 degree, addendum 5 mm, module 5 mm. We know that omega angular velocity is equal to 2 pi n upon 60. So regarding this omega 1 angular velocity of pinion, omega 1 is equal to 2 pi n1 upon 60. So put the value of n1 2000, 2 pi into 2000 upon 60. The value of omega 1 is 209.5 radian per second. Now find omega 2. So with the help of relation between omega 1 and omega 2, it is the ratio omega 1 upon omega 2 is equal to capital T upon small t. So omega 2 is equal to omega 1 into small t upon capital T. So omega 2 is equal to omega 1 having value is 209.5 into 20 upon 40. So we get the value of omega 2, angular velocity of gear 2, 104.75 radian per second. Now find pitch circle radius of smaller gear. So having formula R is equal to small r. It is regarding the smaller gear. So small r is equal to mt upon 2. So m module 5 into t number of teeth 20 upon 2. It is regarding the smaller gear. So having value is 50 mm radius, pitch circle radius. Similarly for larger gear. So it is denoted by capital R is equal to mt upon 2, here capital T, sorry to say, m into capital T upon 2. So 5 into 40 upon 2 is 100 mm. So capital R is 100 mm. Now find radius of addendum circle of smaller gear. So it is denoted by smaller r to the base capital A is equal to small r plus addendum. So 50 plus 5, 55 mm. Similarly, larger gear, radius of addendum circle of larger gear, capital R to the base A. So addendum radius. So capital R plus addendum 100 plus 5, 105. So now what we want to find? The velocity at the disengagement, engagement and pitch point. So where this point, which is shown in this figure, I mention all these point in this figure. So this is the K point, engagement point. This is pitch point P and this L is disengage point. So when the two gears are meshed with each other, having a length of path of contact which is shown over this figure from engagement point K to the disengagement point L. So this is the length of path of contact. So from this figure we can easily get where the length of path of contact. Okay. So next, we know that the distance of point of engagement K from the pitch point P. Okay, so find out the length of path of approach. So length of path of approach is denoted by Kp. So here Kp means length of path of approach and PL means what? A length of path of recess. So having addition is called as total length of path of contact. Okay. So Kp having formula is equal to under root Ra square plus R square in bracket cos square phi under root complete minus capital R sin square phi. So put the value of Ra and R 105 and 100. So we are getting the value of this Kp is 12.65 mm. So it is called as length of path of approach. Similarly, we are finding out the length of path of recess, that is from point P to L. That is from point P to L. This is the recess. Now PL having formula is same, but we are taking the addendum radius smaller circle and pitch circle radius of smaller circle. So put the value of this addendum radius 55 and pitch circle radius is 50. Put this value, phi value is 20. So we are getting the PL 11.5. This is the length of path of recess. Now find the velocity of sliding at the point of engagement. So at the point of engagement means what? This K. Okay. So we know that velocity of sliding at the point of engagement K, Vsk, is equal to having formula omega 1 plus omega 2 into Kp. Kp means length of path of approach. So here the omega 1 and omega, put the value of omega 1, omega 2 and Kp, 209.5 plus 104.75 into Kp, 12.65. So we are getting the velocity, sliding velocity at point K is 3975 mm per second. Now velocity of sliding at pitch point. So pitch point, exactly the contact point, the distance, this is the distance between contact point and pitch point. So Kp, this is the distance of Kp. But when the contact point is overlapped over the pitch point, then having distance is 0. So when you are finding out the velocity of sliding at pitch point, so that distance is 0. That's why at pitch point the velocity of sliding is 0. Okay. Now next, velocity of sliding at point of disengagement, at this L point, disengagement point. So the distance PL, we are multiplying this distance PL to the omega 1 plus omega 2. So the sliding velocity at point L, disengagement point, having formula omega 1 plus omega 2 into PL, distance PL, recess. So PL having value is 11.5, omega 1 and omega 2, we know that the value of this, and we get the velocity at point L, sliding velocity 3614 mm per second. Now last, we are finding out the angle through which the pinion turn. We know that the length of path of contact KL, length of path of contact KL is equal to length of path of approach plus length of path of recess. So 12.65 plus 11.5. So we get the total length of path of contact is 24.50. So here we want to find out the angle. So it required the length of arc of contact. So I mention where the length of path of arc. So the arc which is shown over this figure when the two gear are meshed with each other. So this G point and H point is called as length of arc of contact. Okay. So GH is called as length of arc. It required for to find out the angle. That's why I explain regarding the length of arc. So this is the length of arc. So having dividation is just like length of arc of approach. GP from this point to this point, GP is called as length of arc of approach, and length of arc of recess, PH, from P to H, this is the arc of recess. Okay, so we want to find out the next parameter that I will show you. Length of arc of contact having formula is equal to KL, that means length of path of contact upon cos phi. So we find out the length of path of contact 24, so 24.15 upon cos 20, so we get the length of arc of contact 25.7 mm. Now find circumference of smaller gear, that is called as pinion. So circumference is 2 pi r, but this r is smaller gear. So 2 pi into 50. So we get the circumference of pinion is 314.2 mm. Therefore, the angle through which the pinion turn having formula is length of arc of contact into 360 upon circumference of pinion. So length of arc of contact is 25.7 into 360 upon circumference of pinion, that is 314.2. So 25.7 into 360 upon 314.2. So we get the angle through which the pinion turn, 29.45. This is the answer. So here the angle through which the pinion turn, this pinion smaller gear turn angle, so that angle we want to find. So the complete angle is 360 and the circumference of this pinion is 314.2. That's why we take this 360 upon circumference of pinion. So this is the simple way to solve the numerical which is based on the spur gear. So the two gear are meshed with each other and finding out the different parameter. So this is the easy way to find out. Okay, dear friend. So thank you very much.